Okay, so let's talk about finding the area of a triangle. Now, I already know you know the formula for the area of a triangle. That looks like this. Right? Okay, so here's the deal. If I have this triangle, and the information they've given me is a side, an angle, and a side angle, side triangle, the way I'm going to find the area of this triangle is if I know the base and the height. Well, I don't know the height, do I? Okay, so imagine this. Imagine that we draw or drop, whichever word that you want to use, a perpendicular from this angle all the way down to the base. So since it's a perpendicular, we're creating a right angle, aren't we? And this would represent the height of the triangle, would it not? Now, since I have a right triangle here, either side, but I'm going to just look at the left side of this triangle. Since I have a right triangle, couldn't I use a trig function to help me out? So let's think about this. If I am talking about this angle, which is angle C in this case, and the two pieces of information I know are the height and A. Well, A would be considered the hypotenuse, wouldn't it? And the height would be opposite that angle, wouldn't it? So the sine function I could actually use here would be the sine of angle C, right? That's the trig function I could use here, is sine. So if I try to find the sine of angle C, wouldn't that be the side opposite of C divided by the hypotenuse? Do you agree? Which means I could actually solve for the height, couldn't I? I could get that the height would be equal to A, which was our hypotenuse, multiplied by the sine of angle C. Agreed? Which means I can actually take this formula and I can rewrite it and say, to find the area of a triangle, I'm going to take 1/2 multiplied by the base and multiplied by A times the sine of angle C. Let me just rewrite this a little bit. This would be 1/2 times A times B times the sine of angle C. If you take a look at the locations, angle C is sandwiched between sides A and B. So to find an area of a triangle where I actually don't know the height of it, if I knew one side sandwiched, if I knew one angle sandwiched between two sides, then I could find the area of this triangle by using this sine function, the sine of the angle, and multiply it by the two sides around it. Cool? Okay, so this formula deals with a side angle side triangle. Got it? Okay, we have another formula, and I'm going to write it here, for a side triangle. So if I happen to know the measurement of all three sides, and I'm trying to find the area of this triangle, well, I would have to find the height again, wouldn't I? You know, I don't want to deal with finding the height again because I don't even have an angle to work with. So here's an alternative. An alternative that we use to find the area of a triangle where we know all three sides is called Heron's formula. And Heron's formula looks like this. To find the area of the triangle, you're going to take the square root of this multiplication problem. Now, A, B, and C are the sides of the triangle. And you're like, where does this S come in? What does S represent? Okay, well, S is the semi-perimeter. You know how to find the perimeter of a triangle. What do? You add all the sides together. And semi means you cut it in half. This is Heron's formula. So Heron's formula helps me find the area of a triangle when I know all three sides. If all I know is a side and angle at another side, then here is the formula we use for the side angle side triangles. This one doesn't have a name. This is the formula that goes with the side angle side triangle when you're trying to find its area. Cool? Okay, so hang in there. I've got some examples for us. Okay, so let's look at these two examples. They're asking us to find the area of these triangles. They'd like us to round to the nearest hundredths place. So let's look at the first one. Let's look at what information they've given me. They've given me an angle sandwiched between two sides, correct? On this first one, they gave me a side angle side triangle, didn't they? So remember, I know you're trying to remember the formula, but here's the concept I need you to remember. The concept is this. To find the area of the triangle, it's still 1/2, right? Now remember, the formula we developed said you're going to take 1/2, you're going to multiply it by both known sides, and then you're going to multiply it by the sine of the angle that is in between those two sides. Got it? To find the area of a triangle that's a side angle side, you're going to take 1/2, multiply it by the two sides, and then you multiply it by the sine of the angle that's sandwiched in between the two sides. Cool? Okay, so I know your calculator punching away. If we work on some of the steps, right, we have 33 by multiplying 1/2 times the 6 times the 11, and the sine of 60 degrees. Yep, and then after all is said and done, we get 28.58 square units. Remember, square for area, right? And units, I just put the word units because I don't know what units is in. Is it inches, feet, centimeters? I don't know. So I just put square units. Cool? Okay, so let's look at this triangle. They still want me to find the area. Now notice the information they gave me. It's a it's a side triangle, right? They didn't give me the height here. Just like over here on this problem, they didn't give me the height. So if they didn't give me the height, what I'm noticing, though, is that they gave me all three sides. So if they gave me all three sides for this triangle, then I can use Heron's formula. And Heron's formula says that you're going to need the semi-perimeter, which means add all three sides, and then you divide by 2. Agreed? So I got this to be 11.5. And then to find the area, Heron's formula says to take that semi-perimeter and multiply it by 3 differences. The semi-perimeter minus one of the sides, I said 8. And then take the semi-perimeter minus another side, I took the 6. And then take the semi-perimeter and minus the third side. With me? Okay. So again, I know your calculator punching, but I'm just going to make sure that we're all agreeing on the numbers that we are supposed to be multiplying together. Because if we don't agree on these, then it doesn't matter what you're punching into the calculator, right? So I got 23.53 square units. Good? Okay, so hang in there. I got some applications for us. Okay, so let's look at this next example. The directions haven't changed. They want me to find the area of a triangle. And they said round to 2 decimal places. Well, here's the deal. They gave me the information, but they didn't draw the triangle, did they? So we need to draw the triangle. Now, here's what I need you to remember you need to remember corresponding sides and corresponding angles. With me? So, if I label this angle A, this is angle B, and this is angle C, then the side opposite angle A is side A, little a. And the side opposite angle B is side B, little b. And the side opposite angle C is side C, little c. With me? Okay, and now that I have this corresponding sides and angles set, now I can start filling in the gaps. I know side A has a measure of 6, side C has a measure of 2, and angle B is 130 degrees. So, based upon this information, I have a side angle side triangle, don't I? Do I need to find the height of this triangle to find its area? No, I don't, because I have a formula. And the formula to find the area of the triangle says I take 1/2, I multiply it by the 2 sides, and then I multiply it by the sine of the angle in between those 2 sides. Are you with me? Okay, which means make sure your calculator is in degree mode, and then find the sine of it and multiply it by 6. Correct? Okay, so I don't know about you, but I ended up with 4.60 square units. Good? Okay, hang in there. Got another one. Okay, so let's look at this next problem. Looks like they've given us a story. The dimensions of a triangular lot are 189 feet by 147 feet by 185 feet. If the price of the lot is $3 a square foot, what is the cost of the land? What's the cost of the lot? Okay, so for us visual people, it's not a bad idea to draw it, right? Okay, so we know we have this triangular piece of land, and we know the dimensions of it are 189 feet by 147 feet by 185 feet. Agreed? Okay. I tried to draw one side longer than the other, so if you're like, why did you put the numbers there? Because I was hoping this side was a little bit longer than the rest of them. Anyway, and they're saying the price of the lot is $3 a square foot. So, $3 a square foot, huh? What does that tell you? What do you need to know to find the cost of this land, the cost of this lot? If it's $3 a square foot, the question is, what does square foot actually represent? Some of you said it. Because it said the word square, then square foot means we talking about area in feet, aren't we? Right? And gratefully over here, each of these dimensions is already in feet, isn't it? Or aren't they? So we've got the feet part taken care of, but what we don't have is the area. So guess what we need to find? Good, we need to find the area of this lot, because once we know the area of this lot, then we're able to find the pricing, aren't we? So, first things first. First, find the area of the lot. And so to do that, right, we need this S value because we have 3 sides of a triangle, don't we? And that is, when we have all 3 sides, this is a side, side, side triangle, which means we need to know Heron's formula. Agreed? And Heron's formula says you need to know the semi-perimeter in order to figure out the area. So, I got the semi-perimeter was 260.5 feet. So when we plug that into Heron's formula, Hopefully you're agreeing with the numbers I'm writing. Whoops, except for that one. Clearly it wasn't 206, right? There we go. Let's try that again. So we take that 260.5 and subtract each side from it, don't we? Okay, so 260, okay, gotcha. Now, here's what I got approximately after plugging that into my calculator. And by the way, please do not erase this number out of your calculator because I just put a rounded decimal here. Now this is the area, so it's in square feet, isn't it? So the lot is approximately 12,633 and this many square feet, right? Okay, but that's the area. I still need to find the cost of the land. If I know the cost of the land is $3 per square foot, then what do you think you're going to do to actually find the cost of the land? Excellent. I heard some of you. So second, to find the cost, you're going to take that number that's in your calculator. Again, don't get rid of it. Don't round it. And you're going to multiply it by that $3, aren't you? And when you do that, by the way, do I really need to tell you how many decimal places to round? We're talking money, right? Okay. When you do that, I have that this land is approximately $37,900.90. That's how much it's going to cost them to buy that triangular piece of land. Cool? Okay. Hang in there. One more. Okay, so let's look at this last problem. They're asking us to find the area of the shaded blue part of the circle. I feel like I can't tell which part's blue. It's this part right here that's all shaded, whose radius is 10 feet with a central angle of 70 degrees. So they want me to find the area of just this little section of the circle, so to speak, right? Okay, so notice what they've given us. They've definitely given us a circle, didn't they? But do you notice what else they gave me? Some of you may see it, some of you don't. Do you notice they basically gave me a piece of the pie, right? Isn't this whole thing a piece of a pie? So if you remember, that's known as a sector, isn't it? That's known as the sector. So I have the sector of this particular circle. So, and what else I'm noticing is I have, within that sector of the circle, I have a triangle. And the triangle is from here to here, isn't it? So, how do you think you're going to find the area of the shaded part? Think about it. They've given us the sector of a circle, and within that sector is a triangle. So what do you think you're going to do to find the shaded part? I think I heard some of you say it. You're saying if you could find the area of the sector, because that's the big piece, right? That's that whole piece. And you subtract from it the area of the the area of the, not the circle, but the area of the triangle inside that sector, right? If I take the entire sector and subtract the triangle that's in that sector, the area of that triangle, wouldn't I find just this little piece? Wouldn't this little piece be left over? Good. Excellent. So let's see what we got. Do you remember how to find the area of a sector? Okay. 1/2 times the angle times the radius squared. That's how you find the area of the sector, remember? Area of the triangle. Now, I got to see what kind of triangle they gave me, because it's clearly not a right triangle since that's 70 degrees. But since the radius is 10 feet, then isn't this side of the triangle also 10 feet? So, notice what they gave me. This triangle is a side angle side triangle, isn't it? So, how do you find the area of a side angle side triangle? Good. 1/2 times A, one of the sides, times the other side, times the sine of the angle in between them. Agreed? Okay. So let's start filling in the pieces to our puzzle. The one thing we have to remember is this. For the area of the sector, right? For the area of the sector, theta needs to be in radians. Is that angle in radians? Nope. So that means we need to take 70 degrees and multiply it by the conversion. Agreed? Which will give us 7 pi over 18. Yes? Okay, so let's go back to this formula. Let's start plugging things in. So I have 1/2 times theta, which is 7 pi over 18, times the radius squared, minus, on this one, 1/2 times the two sides, well, the two sides are just both 10, and multiply it by the sine of the angle in between. Now here's the cool thing about this area of the triangle formula. It didn't care if C was in radians or degrees. So I'm going to leave it in degrees. I don't care that this one I had to convert. That doesn't make a difference. I'm going to leave this one in degree mode. Are you with me? Okay, so me personally, I just start multiplying these fractions together. So I end up with 175 pi over 9 minus 50 times the sine of 70 degrees. I usually like to try to simplify first if I can before I start calculator punching. So the only thing you have to be cautious of here is that your calculator is in degree mode, because you're taking the sine of a degree. You're like, yeah, but this was a radian. That's true. You had to convert theta into radians, but you're not taking the trig function. You're not taking the cosine of that, or the sine, or the tangent, or any of the other three. You're not doing anything trig function-wise with this angle. All you're doing is taking this angle, multiplying it by 1/2, and multiplying it by the radius squared. Whereas over here, you're literally taking the sine of the angle, which means you better make sure your calculator's in degree mode. Okay, so you calculator punch. I've calculator punched already, and I got 14.10 square feet, because we're in feet here. Cool? Okay, hopefully this section made some sense to you. It was a great way of finding the area of triangles that were not right triangles. But notice, the only two triangles we dealt with were side angle side and side side side, right? Okay, you have fun with this stuff, and I'll catch you on the flip side.